Since the inception of the West African Senior Secondary School Certificate Examination, university requirement has largely called for 5 subjects. Mandatory among these are English language and mathematics. Every year, thousands of students run into the cause of either having to resit for not getting credits on English and mathematics or painfully changing career path owing to same. To help modify this narrative, Star Television presents on your screen Learning Garage, a platform that guarantees better performance in English language and mathematics with a team of experienced teachers. To this solution, you all are invited, especially those facing WASC. Learning Garage comes to you on Mondays, Wednesdays, and Fridays from 7 p.m. to 8 p.m. Repeat broadcasts are screened on Saturdays from 7 a.m. to 8 a.m. and on Sundays from 1 p.m. to 2 p.m. Join host Ali Sonta Kamara.
If you mean such element, then of course we'll say the waters of the world in that regard.
And Babatunde Gaira Lamin on these days to make a world of difference.
Fraction that has a numerator which is less than the denominator, we term it as a proper fraction. Hello and welcome to Learning Garage. I'm your host Gaira Babatunde Lamin, and I'm your tutor for the mathematics class. And today, of course, we are continuing with our swords. And remember, last week we spoke about operation of swords. Okay, we dealt with operations where you will have situations like this: square root of a plus the square root of b. Okay, and now today we are talking about other situations wherein you have the swords in the form of a denominator. That is to say, the swords appear in the form of a fraction. Okay, remember we said swords are irrational numbers, and these numbers do appear in a way that you cannot simply modify them. Okay, you have to go through other ways wherein you can find yourself a solution. Okay, we are going to talk about situations where you have example, the root of a upon the square root of b. Okay, yes, as we are saying, rationalization of swords. When we mean, what do we mean by rationalization of swords? We say when the denominator of an expression contains a term with a square root. Okay, when a term in the denominator, you remember the denominator is what is the bottom part of a fraction. Okay, we say when it occurs in a way that there is a square root on the denominator, okay, or a number under the radicand sign, the process of converting into an equivalent expression whose denominator is a rational number is called rationalization, or rationalizing the denominator. Okay, what we are saying when we talk about rationalization, we are talking about a way that we can handle, we can get rid of the square root under the denominator. Okay, remember, you cannot solve a sword in a rational form wherein the square root sign remains. Okay, if we happen to have any square root as a denominator, therefore we have to modify or simplify or break that bond. Okay, you have to break it down so that you don't have any factor, okay, in that manner. Okay, in terms of solving a problem, let's look at the different cases. Okay, we say if the product of two rational numbers is a rational, okay, that is to say you are multiplying both numbers which are rational, which are definitely simple, then each one is called the rationalizing factor of the other. Okay, what do we mean by this? If you have the square root of a, okay, the rational form of the square root of a is the same as the square root of a. If you have the square root of b, the rational form of the square root of b is the same as the square root of b. Okay, shortly we are going to demonstrate some of those things. Let's look at our first case. Okay, case 1 says if the denominator is in the form of the square root of a, where a is a rational number. Remember, a is a rational number, but because it is under the radicand sign, okay, that is the square root sign, definitely situation changes. So therefore it's no longer a rational number. Okay, let's see. Okay, I said therefore it goes against says when then we have to multiply both numerator and denominator by the same radicand, okay, by the same rational number. Okay. If we say example, here we say example 1. Example 1 says rationalize the denominator a upon root b. Okay, we have there a, we have a upon the square root of b. Okay, if we are rationalizing this, it means that we are going to multiply both numerator and denominator by the rational term there. The rational term there is what? Our rational term there, we are the rational term. The rational term there is the square root of b. Okay, so if we are going to rationalize this one, it means that a upon the square root of b would be equal to, we multiply both numerator and denominator by the rational value. The rational value there is root b. Okay, so we multiply the numerator a, we multiply it by the rational value, which is the square root of b. What you do for the numerator, you also do for the denominator. Okay, all upon the square root of b multiplied by the square root of b. Okay, okay, so we say we have a situation in the sense that wherein we are going to multiply both numerator and denominator again by the same rational term, which is square root of b. So this gives us what? If we multiply a multiplied by root b, gives us a root b. A root of b all upon, when we are multiplying values under the square root sign, remember we have similar and we have different roots. Okay, if the square root, if what is underneath the square root is similar, that is to say b is always equal to b, then therefore you can match those things as the square of one of them. Okay, if they are different, it means that you are going to represent each of those terms separately. What I mean is that the square root of b multiplied by the square root of b is, say, b times b gives us what? B square. Okay, so we have a root b all upon the square root of b square. But remember, the square root sign represents what? Is a value which is always raised to the power half. So if we say the square root of b square is, this will definitely give us what? A root b all upon b square all raised to the power what? Half. Of course, according to the law of indices, it says when you have a base and you have two separate powers, if there is multiplication or addition, that is the relationship between them, what do you do? For example, if the relationship is multiplication, we multiply the powers rather. That is to say, we have a root b all upon b square multiplied by half. Okay, well, let me bring it down so that we can see. So this is going to be square root of a, this is going to be a root b all upon b square multiplied by half. And that is to say 2 times 1 gives us 2. 2 upon 2 is the same as 1, or we cancel out from this point. 2 is common here and 2 is common here. Okay, so we are going to be left with what? A root b all upon b. So this gives us our final value for the equation. Having said that, or having done that, it means that we have rationalized the surd, which was in the form a upon root of b. Okay, so you see in the final answer that there is nothing like a square root underneath the denominator. There is no square root for the denominator term. Okay, the term of the denominator. That is to say, we have get loose of freed of any square root that exists on our denominator there, which is b. Okay, so this is the first case scenario. Okay, let's take more examples as to how we can go about rationalizing our surds in our first case here. Examples. Okay, we say example 1 here says you have to evaluate the square root of 5 all upon the square root of 2. Okay, the question says evaluate the square root of 5 upon the square root of 2. Okay, so as we said earlier, when we are to rationalize any denominator, we multiply both numerator and denominator by the rational value of that particular equation or that particular rational factor. Okay, that is to say the rational value there is the square root of 2. Okay, square root of 2 is our rational value, so therefore we are going to multiply both numerator and denominator by our rational value. Okay, solution. Okay, we have the square root of 5 upon the square root of 2. So this gives us what? We multiply both numerator and denominator by our rational value, which is root 2. So when we see root 5, we multiply by root 5 by what? Root 2. Okay, similarly, so we do it again for the denominator. Denominator says what? The root 2 multiplied by our root 2. Okay, so this gives us what? Remember, we said again, whenever you are multiplying surds which are of different values, okay, you are going to separately multiply those values underneath. Okay, that is to say 5 multiply the root of 5 multiplied by the root of 2 gives us what? 5 times 2. Okay, upon the square root of 2 multiplied by the square root of 2 gives us what? 2. But how? So we say 2 times 2 all upon the root. Okay, so this gives us again the square root of what? 5 times 2 gives us what? 10 under the root, all upon 2 times 2 gives us 4. So we have root 10 upon root 2. Now how can we simplify this further? But remember, 4 is written as, or 4 is the same as 2 raised to the power 2. Okay, all under the root. And this is also the same as what? Root 10 upon 2 raised to the power 2, all raised to the power half. Okay, we are in 2, our 2 there cancels our 2, so we are left with now the square root of 10 upon 2. Okay, so this gives us our final answer. Okay, so henceforth you have rationalized the equation, you have rationalized the surds there. So it is as easy as that. Let's take another example. Example 2. Rationalize 4 upon root 6. Okay, you have to rationalize 4 upon root 6. Again, we use the same approach, which says what? Whenever you have a denominator under the square root, okay, therefore you have to rationalize, you have to multiply both numerator and denominator by the rational value, and the rational value there is what? The square root of 6. Solution. You have 4 upon root 6. Okay, you have 4 under the square root, 4 upon square root of 6. Again, we are going to multiply both numerator by root 6 and denominator again by root 6. Okay, and this gives us what? 4 times root 6 is what? Is like you saying, remember there is always a 1 in front of our square root sign there. That is a 4 times 1 times root 6. Okay, all upon the square root of 6 times 6. Okay, and this will end up giving us what? 4 root 6 all upon the square root of 36, which is the same as 6 raised to the power 2 multiplied by all raised to the power half. So I'll get our 4 multiplied by root 6. There's another way of writing it, and also we have 6 raised to the power 2 all raised to the power half. 4 multiplied by the root of 6 all upon 6. Okay, but this also we can simplify further. Okay, there are common terms for both numerator and denominator. That is to say 4 upon 6 is the same as 2 is common here, 2, and 2 goes into 6 3 times. So we have 2 upon 3 root 6, which gives us our final answer. Okay, so that brings us to the second example. Let's look at another example. Remember, always when we solve, we are going to be solving also past questions. But before we go into past questions, let's get a general, a broader perspective of what we are saying. Okay, example 3 says what? Example 3 says the cube root of 2 upon 3a. Okay, you have to evaluate this one. Okay, let's say evaluate. We have been talking about problems wherein we have the square root. Okay, now we are going to the cube root. Okay, how can we solve problems under the cube root? There is a problem here which says the cube root of 2 upon 3a, okay, is all upon 3a. Okay, in a situation like this, we are going to, of course, distribute cube root of 2 all upon the cube root of 3a. Okay, cube root of 2 is the same as the cube root of 3a. So now our rational term there is what? The cube root of 3a. How can we then multiply? What are those values that will multiply both numerator and denominator to make our denominator and the root of the denominator disappear? Okay, what we are saying, we have the cube root, okay, cube root of 3a, but we need a value that we can multiply both numerator and denominator. Especially we are doing this because we want to get rid of the cube root sign there. So what is that value? That value that we can multiply for both numerator and denominator. So the rational value there would be what? The cube root of 3a square. What we mean that is to say, if we multiply 3a multiplied by 3a square, this will give us what? This will give us something that will be raised to the power 3, and that 3 will multiply or will cancel out with the cube root. Okay, 3a multiplied by the square root, and the square of 3a will give us what? Will give us, remember, if we are to use the indices approach, you know, 3a is always raised to the power 1. Then because of there is a multiplication relationship between them, we are going to what? We are going to add their powers. Okay, we are going to add the powers. The power here is 1 and the power there is 2. So 2 plus 1 gives us what? 3a all onto this, the power of 3. Okay, again I explain myself again. We want a situation wherein when we multiply the denominator, okay, when we rationalize the denominator, we find a value that will cancel or that will break off the value of the denominator there, which is the cube root of 3a. But the rational value that we can multiply there is what? Is the cube root of 3a square. Okay, so moving on in solving this, we say hence we have the cube root of 2 all upon the cube root of 3a. Okay, so what will this end up giving us? This will be equal to what? We have to multiply both numerator and denominator by a rational value there, which says what? The cube root of 2, we are going to multiply that one by what? The cube root of 3a square. Okay, all upon the cube root of 3a multiplied by our cube root of what? 3a square. So this will give us what? When we multiply, of course, we have what? This man and this man are both, they have the same roots. So therefore, we are going to have the cube root of what? Of 2 multiplied by what? 3a square, all upon the cube root, all over. We have our cube root of 3a multiplied by 3a all square. This gives us now what? The cube root of 2. But remember, we have to first simplify our 3a square. 3a square is the same as what? 3 square there is 9 and a square is a. So you're saying that 2 multiplied by 3 square is 9 and a square is a square. Okay? All under, or all upon the cube root of what? Cube root of 3a. Okay? All raised to the power 3. So this gives us again what? That is 2 times 9 gives us 18. 18a square. 18a square. All upon the cube root, all over. Of course, we have 3a, all raised to the power 3. Definitely all raised to the power 1 upon 3. Okay, we are in 3 multiplied by 1/4 gives us what? 1. Okay, therefore the 3 and both 3 will cancel. 3 is common here in the numerator and 3 is common there for our denominator. This gives us what? This gives us the cube root of 18a square all upon 3a. Okay, but our 3 there is also common for, no, this gives us what? So this ends up giving us what? Finally, the cube root of 18a square all upon 3a. Okay, so that will give us our final answer. Okay, we take a break, and when we come back, we shall solve more problems. Stay tuned to Star TV.
Since the inception of the West African Senior Secondary School Certificate Examination, university requirement has largely called for 5 subjects. Mandatory among these are English language and mathematics. Every year, thousands of students run into the cause of either having to resit for not getting credits on English and mathematics, or painfully changing career path owing to same. To help modify this narrative, Star Television presents on your screen Learning Garage, a platform that guarantees better performance in English language and mathematics with a team of experienced teachers. To this solution, you all are invited, especially those facing WASC. Learning Garage comes to you on Mondays, Wednesdays, and Fridays from 7 p.m. to 8 p.m. Repeat broadcasts are screened on Saturdays from 7 a.m. to 8 a.m. and on Sundays from 1 p.m. to 2 p.m. Join host Ali Sonta Kamara.
If you mean such element, then of course we say the waters of the world in that regard.
And Babatunde Gaira Lamin on these days to make a world of difference.
Fraction that has a numerator which is less than the denominator, we term it as a proper fraction. Welcome back to Star TV, and of course this is Learning Garage. It's a platform for learning for senior secondary school students, okay, and even those that have left school, or even those that want to or have the intention of coming back to making their WAS. Okay, we are here to help in both our mathematics and in our English. Of course, today we are focusing on mathematics, and we are on the topic rationalization of sorts. Okay, so far let's take another example. There's another problem here which says you have to simplify. 10 root 3 upon the square root of 5. Okay, 10 root 3 upon root 5. A solution there, we have 10 root 3 upon root 5. We are again, the first thing that comes up in our mind is to what? To identify, you have to identify the rational value that you are going to multiply, or that you are going to use to rationalize both numerator and denominator. That is to say, a way or a form at which, or a form for which you are going to nullify that square root term there. Okay, we don't need the square root as a denominator, so therefore for you to do that, you have to find a way, or you have to find another way that you can get rid of the square root term. Okay, and that is to say, a rational value there is what? The rational value there is root 5. Okay, so we are going to use root 5. We multiply root 5 by both numerator and denominator, then we solve our problem. Okay, so this gives us what? 10 root 3 all upon root 5. Okay, so this gives us what? 10 root 3 multiplied by root 5 all upon our root 5 there, multiplied by root 5. Okay, moving further in a more advanced form, we have what? We have 10 root 15 multiplied by, 10 root 15 all upon 5. Okay, I know you might be itchy to ask questions. Remember those simple steps that we spoke just now about. We just jump a few steps. That is to say, 3 times 5 under the root is what? 15, and the root of 5 multiplied by the root of 5 gives us what? 5. Okay, so this end up giving us what? 10 upon 5 root 15, but our 5 here is common. 5 can enter into 10 2 times, so this gives us, as you say, 2 times 5 gives us 10, and that is 2 upon 1 root 15. Okay, 2 upon 1 root 15 is the same as 2 root 15. Okay, another example. I believe that the more we practice, or the more we solve more examples, bring us to a clearer or better or brighter future. Okay, under this topic. Example 5 here says you have to simplify. You have to simplify 2 upon 5. 2 upon 5 root 2 upon 5 root 3. Okay, forgive me for my handwriting. Okay, it's difficult to write on this board. 2 upon 5, not the 5th root. Okay, 5 root 3. Okay, so here again we have to identify the rational value that you multiply for both numerator and denominator, that will make the sign or the radical sign on the denominator disappear. Okay, and that value is what? 5 root 3. Okay, 5 root 3 will end up having or giving us a solution. Is that so? The rational value there, we say, is what? The rational value that we are going to use to multiply would be, rational value there is root 3. Okay, root 3 will be our rational value. That is to say, when we multiply, we'll end up having something that will eradicate the radical sign. Okay, so we have 2 upon 5 root 3. This gives us what? 2 multiplied by our root 3, all multiplied by 5 root 3 multiplied by our root 3. Okay, So having said that, okay, 2 root 3 gives us what? 2 multiplied by root 3 gives us what? 2 root 3 upon our 5 multiplied by 1 multiplied by what? Our root 3 multiplied by root 3. Okay, root 3 times root 3 gives us 3. This, and we end up having 2 root 3 upon 5 times 3, which is the same as what? 2 root 3 all upon 15. Okay, so 2 root 3 upon 15, of course, gives us our final answer. Okay, so we are going to solve one of the last problems for this particular case, and then we move on to our next case. Okay, we solve a single problem and then we move on to the next case. Example 6 says 13 upon 9 root 5. 13 upon 9 root 5. Okay, so this gives us what? We have to identify the rational value there that will multiply for both numerator and denominator, which is the root 5, and then we move on. So that is to say 13 multiplied by root 5 all upon 9 root 5 multiplied by our root 5. Okay, this gives us what? 13 root 5 all upon 9 times 1 times root 5 times root 5. Okay, the 5 and the root are almost similar in symbol. So this gives us what? 13 root 5 all upon 9 times 1 gives us 9, and root 5 multiplied by root 5 gives us what? 5. So we end up having 13 root 5 upon 9 times 5 gives us what? 9 times 5 gives us what? 45 rather. Sorry. 9 times 5 gives us what? 45. Okay. So 13 upon 45 root 5. Can we further simplify this one? No. So there are no common values for both 13 and 45. So therefore, we end up leaving it as that. Okay. So we're going to take a short break. When we come back, we move on to case 2.
Since the inception of the West African Senior Secondary School Certificate Examination, university requirement has largely called for 5 subjects. Mandatory among these are English language and mathematics. Every year, thousands of students run into the cause of either having to resit for not getting credits on English and mathematics, or painfully changing career path owing to same. To help modify this narrative, Star Television presents on your screen Learning Garage, a platform that guarantees better performance in English language and mathematics with a team of experienced teachers. To this solution, you all are invited, especially those facing WASC. Learning Garage comes to you on Mondays, Wednesdays, and Fridays from 7 p.m. to 8 p.m. Repeat broadcasts are screened on Saturdays from 7 a.m. to 8 a.m. and on Sundays from 1 p.m. to 2 p.m. Join host Ali Sonta Kamara.
If you mean such element, then of course we say the waters of the world in that regard.
And Babatunde Gaira Lamin on these days to make a world of difference.
Fraction that has a numerator which is less than the denominator, we term it as a proper fraction. Okay, welcome back to Learning Garage, and we are discussing swords. Remember, this is Star Television channel 21. This is a platform for upcoming students who are in the senior secondary schools, and of course who are interested. Of course, maths is a core subject for all for all the streams. Okay, whether be you are a science student, you in arts or commercial, you have to have the foundation of mathematics. Okay, so therefore we are trying to help ourselves, not that we know more, but at least we are just trying to help others. We move on to case 2. Case 2 says what? Conjugate sorts. Okay. First case scenario, we were talking about a situation wherein we have the denominator with a single term under the radicand sign. Okay. Now we are going to talk about another situation wherein you have two different rational numbers, okay, separated by either plus or minus, which are different signs. Okay, that how can we go about rationalizing those forms or those types of situation? Okay, so again, for simplicity, we say conjugate sorts. Conjugate sorts by definition is what? Is a sum and difference of two simple quadratic sorts are said to be conjugate. Okay, when two different, or when two sum, when a sort is separated, or a rational number is separated by both either positive or negative sign, okay, we said they are what? Conjugate sorts. Conjugate sorts are also known as complementary sorts. It can be used to express a fraction which has a common sort as its denominator with a rational denominator. You can multiply you can multiply top and bottom of the fraction by the conjugate of the bottom line. Okay, just as we have been doing when we have a upon root b. We say when we want to rationalize the rational value there, which is root b, we are going to multiply root b for both numerator and denominator. Okay, how can we simplify now? This one is the same method. Okay, just that you have different, there is an addition, a cluster of other sorts. Okay, so we say again the sum and difference of two simple quadratic sorts, example 4 root 7 and root 2, are what? 4 root 7 plus root 2, and the rational form of it would be what? 4 root 7 minus, okay, the root of 2. Okay, that is to say, if you have a positive value for the rational value, then the rational sort would be what? A negative value. Okay, we are saying if we have, example, root a plus root b as the rational value there, then the rational sort of that one, or the conjugate sort of that value, will be what? Root a minus root b. Okay, if you have a negative value for the rational sort there, then the conjugate sort will be what? Positive. Okay, it's like you moving back and forth. When you have a positive value, then the rational or the conjugate sort will be negative. If you have a negative value, then the conjugate sort will be what? Positive. Okay, so these are the situations that we are going to. Let's take an example. Evaluate. Four upon root of 5 plus the root of 3. Okay, solution. We have there 4 upon root 5 plus root 3. We said again, we have to identify the rational value, or the denominator there is what? The denominator is not a single sort. Okay, it's a combination or a sum of two different sorts. That is to say, root 5 and root 3. Okay, root 5 and root 3. Okay, they are not separate sorts though, but they are all under the denominator, or they appear as the denominator there. So therefore, the conjugate of this sort would be what? The root of 5 minus the root of 3. Why? Because we had a positive value there, which is what? Root 5 plus root 3. Now, if we are to multiply by the conjugate of that particular sort, it will be the reverse of that sign. Okay, so of course the opposite of plus is minus, and the opposite of minus is plus. Okay, so the conjugate there, conjugate sort is what? Is 5 root 5 minus root 3. Okay, root 5 minus root 3. So we have to multiply both numerator and denominator by the square root of 5 minus the square root of 3. Okay, so I think we need to do that now, which says 4 upon root 5 minus our root 3. This gives us what? 4 multiplied by root 5, okay, minus root 3. Okay, we introduce a bracket there so that we can separate the terms. Okay, and then you have again 5 root 5. Let me write it proper. Okay, root 5 there minus root 3 multiplied by, again, this will be positive rather. Sorry. Okay. This should be positive. Okay, that was a mistake. So if we had originally a positive sign there, when we multiply by the negative value. Okay, so we say again 4 upon, there's nothing changes, but we just had to make amendments for that. It was my own error, which says what, instead of bringing up down the positive sign there, I place it to be negative. Okay, never mind. We have now multiplied by the conjugate there, which says what, the root of 5 minus the root of 3. Okay, so this brings us to another level. We are going to multiply 4 by each of the square terms there. Okay, by each of the square root terms there. That is to say 4 multiplied by what is underneath. Anyway, I think we are going to leave it in this form for now. Root 5 plus, this should be minus rather. Remember, we are multiplying by negative value. Is minus root 3. Okay, all upon 5. Remember, when you have a difference of 2 square, for example, as the case may be here, we are going to do separate term factorization, meaning we have to factorize, or we have to multiply first our root 5 by what is inside the bracket of the second term, and also our root of 3 we multiply again by what is underneath our bracket there. So we take them separately. We say root 5 multiplied by into the root of 5 minus root of 3 plus, because since there was a plus sign in front of root 3 there, okay, plus root 3 multiplied by root of 5 minus the root of 3. Okay, so there is no need to press the panic button because we are going to expand. Okay, you cannot see an expansion and say, oh, math is difficult. Okay, just follow and pay attention, and then you practice. If we evaluate again further, we say we are going to have 4 into the root of 5 minus the root of 3 all upon. Now we are going to multiply. Root 5 multiplied by root 5 gives us what? 5. Then root 5 multiplied by root of minus 3 gives us what? Minus root of what? 15. How? 3 times 5 gives us what? 15, or 5 times 3 gives us 15. And also plus, we say plus because we are multiplying plus root of 3. Okay, so root 3 multiplied by root 5 gives us what? Plus root of 15. Okay, plus times minus gives us what? Minus, and root 3 multiplied by root 3 gives us what? 3. Okay, is equal to, we have now end up having 4 into the root of 5 minus the root of 3 all upon. Now we have 5 minus 15 plus 15 is 0. Okay, it's like you saying, I'll give you this orange and then I'll take it back. What do you have next? You have nothing. Okay, so therefore you are going to say these are minus 15 cancels, are minus plus 15. Okay, so we end up having 5 minus 3 as our denominator. I think we are making progress, which says 4 into the root of 5 minus root of 3. Okay, all upon 5 minus 3 is what? 2. Okay, you have 5 mangoes and you're asked to give Abdul 3 mangoes. What will remain? And of course we have both common values for our denominator and numerator. We see that 4 and 2, 2 can enter into itself once and it can enter into 4 what? 2 times. So 2 here is 1, 2 into 4 is 2 times. So we end up having 2 into the root of what? The square root of 5 minus the square root of 3. Okay, so this will be also written as also what? 2 root 5 minus 2 root 3. So either of them I think is correct. Okay, so I hope we understand that particular sort. We take another example. Example 2 there says you have to evaluate 2 plus root 3 upon root of 2 minus the square root of 3. Okay, you have 2 plus root 3 upon the square root of 2 minus 3, the root of 3. Again, we try to identify the conjugate of this particular sort. The conjugate of this sort is what? Is the opposite of the denominator. That is to say, is the opposite of the sign of the denominator. We are having minus as what? The relationship between root 2 and 3. So therefore, our conjugate of this particular sort would be what? The root of 2 plus, not minus, the root of 2 plus the root of 3. Okay, the conjugate sort there is what? The conjugate sort is what? Root 2 plus root 3. Okay, so therefore we are going to use this conjugate to multiply both numerator and denominator. Okay, so this gives us what? 2 plus root 3 all upon root 2 minus, because this was originally there, minus we are just bringing the problem down again. Of course, this will give us what? We say we multiply both numerator and denominator by the conjugate sort. The conjugate sort there is what? Root 3 plus root 2. Okay, bringing this up further, it says what? 2 plus root 3, okay, multiplied by okay, for the sake of space I'll just then multiply directly here. So we multiply here by what? The conjugate, which is the root of 2 plus the root of 3. What you do for numerator, you do also for denominator, and you multiply here again 2 plus root of 3. Okay, so now we are going to multiply. Pay attention. Okay, we are going to multiply our 2 there by what? Root 2 plus root 3. Okay, as you see, 2 multiplied by root 2 gives us what? 2 root 2. Okay, 2 multiplied by root 2 gives us what? 2 root 2 plus 2 multiplied by root 3 there gives us what? 2 root 3. Okay, plus again we multiply root 3 multiplied by root 2. Root 3 multiplied by root 2 gives us what? 2 times 3 gives us 6. Okay, that is root 6. And then we have root 3 multiplied by root 3 gives us what? 3. Okay, all upon, again we multiply the denominators. Denominator there is what? Root 2 minus root 3 multiplied by what? Root 2 plus root 3. We take it step by step. We take our first term there, which is root 2, which says root 2 multiplied by root 2. Root 2 multiplied by root 2 gives us 2. And then root 2 multiplied by root 3 gives us what? Since there is a positive sign in front of root 2 there, it is what? Root 6. Okay? Then we say minus times plus gives us, of course, minus root 2 multiplied by root 3, or root 3 multiplied by root 2 there gives us what? Root 6. Okay? And then minus times plus is minus. Root 3 multiplied by root 3 gives us what? 3. Okay? Making progress so far. So this gives us what? We are going to either collect like terms or see how we can do best around this, guys. Okay? Of course, there are different roots there, which are what? Root 2 plus root. There is a root 3 there, and also there is a root 6, and there also we have 3. So of course let's maintain our numerator there, which says 2 root 2 plus 2 root 3 plus roots of 6 plus 3. Okay, this is plus, all upon our what? 2. Okay, now we are going to evaluate root 6 minus root 6. Okay, of course they cancel out, it's 0. Okay, so you end up having 2 minus 3. Okay, so this gives us what? This gives us what? For our denominator, again we maintain the numerator. Okay, we are trying to do it step by step. Okay, this is plus 3 all upon 2 minus 3 gives us what? Minus 1. Okay, so when it is minus 1, of course we bring a minus sign in front there. Of course this applies for both numerator and denominator. It affects both numerator and denominator. Okay, so this is minus into what? Minus 1, or you say minus 1 or minus into 2 root 2 plus 2 root 3 plus root of 6 plus 3. Okay, so this gives us our final answer. Okay, we cannot further reduce or simplify or add or subtract simply because the roots there are different. Okay, if they were the same example, if you had root 2 plus root 2, then you can add those ones. Okay, but since the values are different, therefore we leave them as we see them. Okay, no sooner you touch them, then you are making a great error. Okay, so far so good. I think we've learned something. And don't forget, this is Learning Garage. You are watching Learning Garage on Star Television. Okay, we shall take a quick break, and when we come back, we look at past questions. Okay, we try to see how we can solve past questions from those exams that we ourselves and our colleagues have been taking. Okay, stay tuned to Star TV, Learning Garage. We'll be right back.
Since the inception of the West African Senior Secondary School Certificate Examination, university requirement has largely called for 5 subjects. Mandatory among these are English language and mathematics. Every year, thousands of students run into the cause of either having to resit for not getting credit on English and mathematics, or painfully changing career path owing to same. To help modify this narrative, Star Television presents on your screen Learning Garage, a platform that guarantees better performance in English language and mathematics with a team of experienced teachers. To this solution, you all are invited, especially those facing WASC. Learning Garage comes to you on Mondays, Wednesdays, and Fridays from 7 p.m. to 8 p.m. Repeat broadcasts are screened on Saturdays from 7 a.m. to 8 a.m. and on Sundays from 1 p.m. to 2 p.m. Join host Ali Sonta Kamara.
If you mean such element, then of course we say the waters of the world in that regard.
And Babatunde Gaira Lamin on these days to make a world of difference.
Fraction that has a numerator which is less than the denominator, we term it as a proper fraction. Yes, hello, welcome back. This is Learning Garage. As we are rounding up, we want to just tackle one or two past questions together, okay? And our first question there says we have to simplify the root of 108 plus the root of 125 plus the root of 75, okay? And this came in June 2018. Remember, June 2018, last year, okay? So therefore, we move on without wasting any time. A solution there says what? We have to simplify the root of 108, okay, plus the root of 125 plus the root of 75, okay. Like I said, you don't need to panic, okay, having seen those big numbers. Root of 108, okay. Remember we said when we are simplifying, especially natural numbers, you have to find either perfect squares or perfect roots or something like that, okay, so that when we multiply or when we scatter, when we separate those numbers, you have a perfect square there or a perfect root of a particular number, okay. It's like you saying you're trying an elimination method. Or of course, what are these perfect square, or what are one or two of these perfect square that we can multiply which will give us 108, or which will give us 125 and at the same time 75, okay. That's all we are going to do. So find two numbers which we multiply. At least one of them is a perfect square or a root, a perfect root. 108 is like you saying 30. You're saying 36, yes, multiplied by 3. Okay. Let's try 36 multiplied by 3. Remember, 36 by 3 gives us what? 108. And 36 is a perfect square. Okay. Plus 125 gives us what? 25 times 5. 25 times 5 gives us what? 125. Wherein 25 also is a perfect square. So 75, we'll break it down to 25 times 3. 25 times 3 gives us what? 75. So 25 times 3 gives us 75. So we end up having what? The square root of 36 multiplied by 3 plus this by root of 3 plus the square root of what? 25 multiplied by the square root of 5. Okay, we distribute this again. We say the root of 25 multiplied by the root of 3. So the root of 36 gives us what? 6 multiplied by the root of 3 plus the root of 25 gives us what? 5 multiplied by 5 multiplied by root 5, and finally we have again the square root of 5. 25 is 5 multiplied by root 3. Okay, so we end up having what? 6 times root 3 gives us what? 6 root 3, then plus 5 times root 5 gives us what? 5 root 5, and plus 5 times root 3 gives us what? 5 root 3. Can we add or subtract? Are there any two roots or the same roots there that are similar? We have similar roots. Yes, we have root 3 and root 3. Okay, so we can add or subtract that one. So we have 6 plus 5, okay, root 3 plus 5 root 5. So this gives us what? 6 plus 3 gives us 11. Gives us 11 root 3 plus 5 root 5. Okay, so that gives us a final answer. The final answer there says what? 11 root 3 plus 5 root 5. Okay. to simplify the square root of 12 into the square root of 48, okay, minus the root of 3, okay. This one is June 2014, okay, June 2014. Solution. Solution there, okay. We have a problem there which says simplify the square root of 12 multiplied by the square root of 48 minus the square root of 3, okay. So let's break this down a little bit. This is root 12 all into the root of 48 minus the root of 3, okay. So this gives us, what about 12? 12 is the same as 4 times 3, and 4 there is a perfect square. We say 4 multiplied by 3 all under the root, all into the root of 48. The root of 48, we say 16 multiplied by 3, or 16 multiplied by 3 gives us 48. 16 multiplied by 3 gives us 48 minus, of course, this is root 3, okay. Bracket closes. So we say 4 multiplied by 3 under the root gives us what? 2 root 3, okay, all into 4 root 3 minus our root 3, okay. So what do we have there? We have 2 root 3 all into what? 4 minus 1 gives us what? 3 root 3, okay. So if you multiply 2 root 3 multiplied by 3 root 3 gives us what? 2 times 3, that is to say 2 times 3 multiplied by root of 3 multiplied by the root of 3. This gives us finally 6, which is 3 times 2, or 2 times 3 gives us 6 multiplied by 3 root 3 multiplied by root 3 gives us 3. That is to say 6 times 3 gives us 18, which will be our final answer, okay. So far so good. I think we shall end up with this one as a problem for you. When you go, I think you can solve this one in your time, okay. I'll leave you with this problem which says you have to simplify 2 root 3 minus 6 upon root 3 plus 3 upon root of 27. This came June 2010, was June 2010, okay. So thank you very much for being with us, for joining us on Learning Garage. I've been your host, Gaya Babatunde Lamin, and of course I shall leave you with this problem. So when we come next, we solve together as to how you have practiced. Maybe you have the answer, or maybe there are some 1 or 2 steps that you jumped or you cannot understand. So we're going to solve this one in our next class, and when we come, we move on to maybe the next step. Thank you very much for being with us. This is Star Television. I've been your host, Gaya Babatunde Lamin. See you next time.
Since the inception of the West African Senior Secondary School Certificate Examination, university requirement has largely called for 5 subjects. Mandatory among these are English language and mathematics. Every year, thousands of students run into the cause of either having to resit for not getting credit on English and mathematics, or painfully changing career path owing to same. To help modify this narrative, Star Television presents on your screen Learning Garage, a platform that guarantees better performance in English language and mathematics with a team of experienced teachers. To this solution, you all are invited, especially those facing WASC. Learning Garage comes to you on Mondays, Wednesdays, and Fridays from 7 p.m. to 8 p.m. Repeat broadcasts are screened on Saturdays from 7 a.m. to 8 a.m. and on Sundays from 1 p.m. to 2 p.m. Join host Ali Sonta Kamara.
If you mean such element, then of course we say the waters of the world in that regard.
And Babatunde Gaira Lamin on these days to make a world of difference.
Fraction that has a numerator which is less than the denominator, we term it as a proper fraction.